be understanding unit vectors. Yesterday we talked about vectors in general. Tell me something about vectors. They have two things, a what and a what? Direction and a magnitude. It's like how big are they and where are they pointing. Okay, two things. Difference between vectors and lines are usually when you're doing points and lines you don't care about order, but with a vector it's a very specific starting point and the ending point. And the ending point is called the what point?
Q.
Yeah, we called it Q, but
Or
the terminal point, right? So you start here, you go there, and you got to be mindful that the order does matter. You can't just do any order like you can when you're working with a line. Okay, so what is special about a unit vector? Tell me one thing special.
It has a magnitude of 1.
Yeah, it's a vector that has a magnitude of 1, so you sort of take the magnitude part out. And the way you do that is you can take any vector, v, and you can turn it into the unit vector. So I'm just going to call that u. Is a unit vector is a vector. Okay, unit vector of v, the unit vector of v is equal to v over the magnitude of v. Okay, and I should put vector there. V is a vector. The magnitude of v is a
of 1.
well, no, I mean just in general, the magnitude of a vector is it's a number, right?
Oh,
So
yes.
as we're working with vectors, the secret to success is keeping track of what's a vector versus what's a number. So I have a vector divided by a
Number.
so I'll end up with a vector. And because I'm taking the vector and dividing out its magnitude, I'm going to end up with 1. Okay, so that makes it 1. And so the easiest way to find the magnitude of a vector is to do what?
The square root.
Square root of
Vector, like v1
squared.
plus v2 squared.
Okay, and so the vector v is the vector some number v1, some number v2. Okay, so v1 and v2 are numbers, but when we put them together with brackets around them, we get a vector. Does that make sense? So you take the square root of the first one plus the square root of the second one, and you end up with a magnitude. So that's how you go to a unit vector. Does that make sense?
Yes.
We have two special unit vectors. Okay? We have the unit vector I, all right, and that is equal to the vector 1, 0. Okay, the vector 1, 0. And we have the special unit vector j, which is equal to 0, 1. So if we look at that, if you think of the coordinate axis, it's sort of like this is the vector I. This is the vector what? J. You can probably guess there's one more special unit vector, and that's the one coming out of the board.
W.
Yeah. Okay. Does that make sense?
Mm-hmm. Oh. Mm-hmm.
What did you say?
Nothing.
Okay.
Continue.
Is that all good? Okay. So those are, I is a unit vector along the x-axis, and j is a unit vector along the y-axis.
Okay, I have a question.
Yes.
In the book, there was one that used W. What is W?
It
another version of just B.
yeah. So w is just a vector, right?
Oh.
Okay. It's not a special one
Okay.
yet. All right. Okay, so now what you have to see is, and again, it's keeping track of what's a vector and what's a number. So let's say I have v is equal to v1 and v2. Okay? V is a what?
A vector.
And it has how many numbers associated with it? v1 and v2. Okay, so we see that that's a vector, right?
Yes.
This is a new way to write that vector. We could have V is equal to V1. V1 is a what?
Numbers.
Yeah, so if I say V1 is 14, what do you still need to know? The direction.
Mhm.
Okay. Yeah, to turn it to a vector, we need the size. The size is what? And now we need a direction. What do you think the direction would be given that it is this number? I. And I is a what?
I is a vector.
Yeah. Plus, see if you can tell me what you think the next...
J.
J. Okay. And what would go in front of J?
V2.
V2. All right. And guys, really, I know it sounds like I'm repeating myself, but if you can keep track of what are numbers and what are vectors, it'll make sense. V is a what?
A vector.
V1 is a what?
A number.
I is a what?
Vector.
V2 is a what?
Number.
J is a what?
Vector.
Okay, so let's think. Okay? Let's say we have vector V is equal to 3I plus 4J. What did I do here? I just told you what V1 and V2 were, right?
Yes.
We're working an example. So tell me on this axis what this would look like. Like, tell me what this would look like. Or just talk out loud about this.
It would look like an arrow going from 0, 0 to the point 3, 4.
No, you're right. But let's break it down. You've got to understand each component.
So
What does
could
this
you,
do? What?
So could you, like, where the I and the J are, could you fill in the vector, since we know, like, I is the vector 1, 0, and then you distribute the 3 in it?
Yeah, okay, so tell me what that looks like. Tell me to draw something. Now, Ben wanted to tell me the answer, but we have to understand how the answer comes from each little part. Okay, so you were not wrong, but we've got to make sure everybody understands exactly what I think you just did in your head.
So I is 1,
I is like that, right?
yes, 1, 0.
Okay.
And so you'd have to multiply it by 3.
Okay. So tell me what this vector represents here, from over here.
3i.
Oh, 3i.
3i, not V,
Okay.
3i.
Okay.
Okay.
Yes.
Now, Catherine, tell me what you want me to do.
Okay. Well, J is 0, 1,
J is 0, 1.
and then you have to multiply it by 4, so you need to go up.
Okay. So we go like that. Don't draw the little arrows, just draw it as 1, but you see how we got there.
Yes.
Now, if I have this plus this, I get what?
That.
This is what? This.
That is the vector V.
This is V. Okay. This is what?
3i.
3i. And really, what you did was okay, but it's better, like, trace this out. This takes me where?
That takes you.
Here. And then what should I do from here?
Go
Where
up.
the one takes you.
Like that. You see, it's a little easier if you draw it out here.
Yes.
It's like you're driving.
Mhm.
Go 3 blocks east and 4 blocks north. Okay, you see? And now this is vector V. So what would this represent here? 4J. Okay? Do you see how that really kind of makes a lot of sense?
Yes, sir.
Okay. So, I want you to put vector V is equal to 7, 4. I want you to put that in unit vector format. Catherine, can you take a shot at that?
Yes, sir. 1 second. Let me finish writing
So we're putting it in what again?
Unit vector form.
Okay.
Okay.
Right now we're in component form, right?
Mhm.
Okay, this is component form. What do I want now? Unit vector form. So what's
Yes.
that going to be?
Okay, so vector v is going to equal 7i plus 4j.
Right. Do you see how this makes sense? It's kind of like then, it's like you go over 7 and up 4. Okay, so now let's start with one where we kind of go through the whole thing. All right. So I'm going to give you a P and a Q, okay? And we're going to talk about the vector PQ, okay? And I'm going to tell you P is 2 minus 5. Please forgive me that this probably isn't going the right direction. Minus 1, 3. Okay? So, the first thing that we want to do is we want to get this into the unit vector form. If I'm going to go to unit vector form, the first thing I need to get it into is what form?
Component form.
Component form. So tell me how I would do component form. And don't tell me numbers, tell me what this would go into, what this would be.
Q1 minus P1. Q2 minus P2.
Okay? Because the Q, it's the Q1 minus the P1, comma, and then you kind of do the Y's, the 3 minus a minus 5. And the order matters, so tell me numbers here, Ben.
So then Q1 is
Negative 1
minus 2.
minus 2, okay.
And then 3
Uh-huh.
minus negative 5.
3 minus a negative 5. And so then what we could say is vector V is equal to, in component form, what?
It would be negative 3, 8.
Negative 3, 8. Okay, now, if I wanted to put this in the unit vector form, that would be what?
That would be negative 3i plus 8j.
Right. Is this easy?
Mhm.
I think it's pretty easy. Okay, we're going to go on. Okay, now we're going to look at vector operations. Let's see, let me ask you this. How much homework can you go through with what I've just shown you?
So problems 34.
We can do 35 and 36 and 43, 44, and 45.
Okay, are there any other I's and J's later on that you could do?
We can do 50, 60,
Okay,
50.
Tanner, you can finish now. That's what we're doing today on understanding unit vectors. Okay, so what did
We did 14 through 16.